Hey, how you doing? I'm Bob Lee. I've been in pro audio for 40 plus years. I've been RF bug for a long time and playing around with radio since I was a kid. And I'm a ham radio operator. I've done live sound, especially for theater, for since like around 1980, and done a lot of work with wireless mics. I worked for Sennheiser 30 some years ago. I did a lot of uh, built, serviced, and maintained a lot of wireless mic systems for theaters like Broadway, broadcast networks, concert tours, and stuff like that. And I'm excited to be with RF Venue now. I've been with the company about 3 months. It's cool to play around with antennas and stuff like that again. Some of you might remember me from the years I spent at QSC. Um, in between QSC and now, I was also a head audio engineer at a nearby professional theater called the Iverton Playhouse in Connecticut. And so there you know, got to work with actors and sound designers and directors and audiences and stuff like that with wireless mics. And so we're here to talk today about the RF Explorer Pro, which is a new product from RF Venue. So if you're probably familiar with our company, if not, we make tools for wireless mics and in-ear monitors so that we can make wireless audio just work better and more reliably. Okay, so the RF Explorer Pro is this sort of a large tablet device with it's it's made for RF use, optimized for wireless mics and in-ear monitors, although it spans a huge range of frequencies. And the importance of this product is growing, as you know, with time because our UHF spectrum available for wireless audio is getting smaller and smaller over time because the FCC has been auctioning off segments of the UHF spectrum. They started from the top and worked their way down. Now we're down to just 470 to 608 megahertz. It used to go up to almost 900 megahertz, and I remember at Sennheiser we actually you know put out some systems that were operating up around 950 megahertz. We don't have that available anymore. It's shrunk down a lot. We've got more UHF TV broadcasts allocated into that smaller spectrum. So the old days of just flying blind, um, hoping that you won't get interference, those are gone. So if you're uh, serious about doing wireless mic systems, you really need a tool like this to look at the RF environment that you're working in. Okay, so let's get into the device. There are features in the unit that you buy from RF Venue that include a license to activate. And so these are not present in the base model, but in the RF Venue, RF Explorer Pros, there are licenses that unlock these features. So first among them is the extended range out to 6 gigahertz. And that's a permanent license that you get when you buy from RF Venue. The base model only goes up to 3 gigahertz. And we'll go into how you activate those licenses to begin with. The other license that you get is the frequency coordination mode. Okay. And that, again, is a permanent license, and it includes the cable test feature. We're going to be going into all these functions a little bit later. Okay. There's built-in Wi-Fi channel analysis. This is not just a spectrum analyzer, but it is a multi-tool. So it has different modes of operation. One of them is Wi-Fi analysis, and you can look at the individual Wi-Fi channels and their signal strength and stuff like that. It's good for troubleshooting Wi-Fi problems, and a lot of audio gear now is Wi-Fi enabled, including like mixers and other bits of gear. There's a touchscreen interface, being a tablet. You can actuate all the functions and stuff like that via the touchscreen. You can also do it remote control um, through a VNC network. Okay, and that involves connecting the RF Explorer Pro to a LAN, a network, uh, and using a VNC viewer app on your computer or tablet or phone or whatever you're doing, and then you just connect to the VNC server that's built into the unit, and that gives you complete remote control uh, right out at remotely from the RF Explorer Pro. Uh, it auto records the scans that it does, and you can play it back over time. Now, there's a slider down here, allows you to go back in time and review what may have happened in the RF spectrum. So if you're doing a show and you hear an RF hit or something like that, maybe you can go back and find that intermittent event that caused the problem, and maybe for the next show or something like that, be able to work around it, and you can save the scan data as a CSV file. That's like a spreadsheet type format um, file where the values are separated by commas or whatever character you designate when you set it, and that can be imported into various wireless um, spectrum or frequency coordination programs um, to use as when you select your wireless mic frequencies. You can also use that for troubleshooting. Let's say if you're a consultant or you're working with a consultant who and you have a encountering wireless interference problems, you can say, I'd like to see a scan of that. You can send the CSV file and use that as a basis for analysis. It's compatible with Wireless System Builder, which is a RF venue tool online, Wireless Workbench, and other various brand specific frequency coordination programs. And it uses a Windows operating system, so you can go in and set various parameters in Windows for networking and finding the IP address, because the IP address is necessary for when you use the VNC viewer. It has a 1/4x20 tripod mount here on the bottom, so you can set it up on a stand and have it readily visible. It includes a 5-volt, 2-amp charger and a cable. And believe me that it it needs a 2-amp charger. I've tried running it on smaller chargers, and although you get longer life than if you just rely on the internal battery, it will eventually run out. But the 2-amp charger will keep it going indefinitely. Includes 2 antennas. One is this stub whip antenna, multi, it's a wideband antenna, and there's also a blade antenna, which is for like say 900 megahertz and up. That's really good for use with for troubleshooting Wi-Fi and stuff like that. And let's look at the connections. First, there's the charge port. It's a USB-C, and there's a micro HDMI port, so you can hook up an external display. Oops. Let's go back. Okay, sorry. The There's an SMA RF input, which is where the antenna screws into. Now, this is what you would use for anything where you were putting RF into the device for analysis. You can use the antennas that come with it, but if you're troubleshooting or analyzing a wireless mic system or something like that, it's even better to just use an unused distro output on your system, or hook up to the antennas that you're using directly. Of course, you can only do one at a time rather than both, but this will allow you to see what the antennas are seeing, which might be more valuable than just putting on the one of the included antennas. So that's a little user tip there. It has a selectable minus 30 dB attenuator also, and I think of the wireless mic transmitters that I've serviced, even recently when I was working at the Playhouse. We're one of the few venues where we would do actually some in-house servicing on the wireless mic transmitters. This would have been handy to have, just to verify that the transmitter is working again after I serviced it. So that minus 30 dB attenuator, it makes it really useful for testing transmitters. There's an RF generator output, which is this little guy here. These are dust caps over the SMA connectors, and that's useful for some of the modes, including the cable testing and the tracking SNA feature, which is a scalar network analyzer, and we'll be getting into that a little bit later. There's an audio output for alerts also, so you can set different parameters for alerts in the audio. Okay, so let's look at what you would have to do to get started. When you get one of these new out of the box, first thing I would say, plug in the charger, because the battery is typically not fully charged. Now, the battery on this thing will typically last at least about 3 hours, but doing all this processing and stuff like that and driving the display, that takes a lot of juice. It's a substantial battery, so I would say do what you can to plug it into the charger if you're going to be running it for more hours, a longer time than that. Or if you have like a pretty substantial USB power bank, if you're going, remote or something like that, then that's a good thing to have. Then you want to turn it on, and you get the serial number at config, then about. So on the menu here on the right, you'll see config. Just tap on that, and then you'll see a splash screen with the firmware version number indicated. That's important to know, but what you want to do first is get to the next window, which is about. You'll see the serial number. Included with the device is a little piece of paper with a QR code. Go to that, use that QR code to register the device online with the serial number and with your email address. That's important because that's how you're going to get the license keys to unlock those two features that I told you about. Okay, and you'll also want to download the latest firmware installer. And just in case you don't have the latest firmware, currently is 1.11. something, and that has all the latest features and correction of any little bugs and stuff like that. But you'll definitely want to have the firmware always up to date. Now, as the firmware updates in the future, we will be adding some capabilities as possible. So this is a good way to actually have a better unit later on than what you actually started with. Now, one of the inputs on this device is a GPS antenna input, and that's another good use for the blade antenna. Now, it doesn't have the GPS features utilized in the device yet, but in future updates of the firmware, we anticipate having some GPS functionality in there. So there are directions for updating the firmware. It's really easy. If you unzip the installer file, you'll get an executable um, installation file. Just put it on a thumb drive, put it in here, and just go to the Windows environment, select that file, and run it. And within a couple minutes, it will update the firmware. Okay. When you download the two email license keys, those are two files. They're about 16 gigs or 16 kilobytes each. Put them on a thumb drive, reboot the device with the thumb drive installed, and it will automatically look to the key files and unlock those two features. Okay. So to interface with a VNC network, what you would use is a BNC or um, USB to Ethernet adapter, and that allows you to connect to your network and really just connect the device that way. Once it's connected to the network, it will gain an IP address. So then, if you go into the Windows environment on the tablet, go to settings, look at network, um, find the IP address, then you can use that with the BNC viewer to connect to the device. You can also get the IP address if you happen to have like a Discovery app, say on your phone or something like that. I have one that's called Thing, and that finds devices on the network and reports their IP addresses too. And that's another way to get the IP address. But you'll need that for the VNC viewer. Now, what we use is Kite VNC because the device has a Kite VNC server built in. Other VNC viewer apps, I have several, and they will work too. They all pretty much work the same. Just put in the IP address and then connect to the device, and you'll have full display, excuse me, and remote control of the unit. It'll bring all the touchscreen functions out to your computer or phone or whatever. So instead of touching the screen on the device, you can actually use your mouse and click on the buttons. Now the default mode is the spectrum analyzer. The excuse me. The frequency range we're mostly interested in for wireless mics and in-ear monitors is 470 to 608 megahertz, and we share these with UHF TV broadcasters. The waterfall, the 2D waterfall underneath, uh, is good for finding persistent signals that might be otherwise be obscured by the real-time spectrum analyzer line bouncing up and down. Okay. Now, this is the RF environment at my house in Chester, Connecticut. I live in the woods. I have hills all around me. I can't even pick up any TV channels. So I've got a pretty quiet environment. The Ireton Playhouse where I worked at before, it's only a few miles away, had a very similar quiet RF background. Okay. So you can see there's a little bit of a signal. One of the signals from a TV station is getting through. digital TV signal is a bunch of different individual carriers, each carrying digital information, and one of them is getting through a little bit stronger. But I don't have the whole TV channel there, but it's this is from 500 to 600 megahertz, and so this is what I deal with at home. Pretty much nothing. Okay, now if there is a TV channel in your area, it will show up pretty easily as a 6 megahertz wide block of increased RF energy. If you see a single 6 megahertz wide uh, block of RF energy, that's one channel. You might see 12 megahertz, and that's two DTV channels together. Continuous channels. You might see 3 or 4 altogether. That's something we can do with DTV now that was not really didn't work too well with analog, but now they're tightly packing RF TV channels in the RF channels in the UHF spectrum, and that's something we have to be aware of because those are licensed users. They're licensed by the FCC to use those chunks of frequency. We can't stomp on them. It's illegal. They're For one thing, it would deteriorate our uh, wireless performance. Plus, it would interfere with their licensed signal. So you're asking for trouble if you try to compete with the local TV broadcasters. And let's see, the next features we're going to look at are power channel and the 2D, 3D waterfall. Now, the power channel lets you read the RF energy levels, RF signal energy in a defined frequency band. Now, you can go into config, just like you can with the spectrum analyzer, and configure the range of frequencies you want to look at. This is more of an advanced feature. Most run-of-the-mill applications, most users probably won't need this, but it's there for if you're doing advanced work, like if you were, say, an RF, wireless mic consultant, you're designing systems or whatever. This is a good tool to have. The waterfall display gives you a look at the RF spectrum with the amplitude, frequency, and time, each as an axis on the display. Now, this is the 3D waterfall. You have a choice of several different perspectives of the 3D. There's also 2D available, which is very similar to what was under the spectrum analyzer display. Okay,
Hey, Bob, I was
yeah,
just going to say we can catch up on some questions. I did answer them written, but we can go over them again.
okay.
So, and I know you went over the ports in a sense, but the input port, the question is, does the attenuator setting protect the internal board? And I answered yes. You would attenuate if you're measuring transmit signals at a certain level. You don't want to go beyond the limits, which is around 24 dBm input.
Yeah.
So that there's certain settings of attenuation that are already preset in there. And for example, if you're measuring an output of a transmitter connected, yes, you would have to figure out what the level is coming out of that, which is if you're at a quarter watt out of the transmitter, you're 24 dBm. So attenuate if you're going to be above that.
Yeah.
And then the other
safe. Oh, yeah. The RF input is safe to use with any wireless mic transmitters. You wouldn't use it for a CB or a ham radio or broadcast transmitter or something like that, because you'll burn out the input circuitry. Okay.
The other question What was the name of the preferred phone networking app? I think they're talking about the VNC app. Uh,
Oh,
so
type type VNC is what we use,
yeah, and I use
but
a remote Ripple for my Mac.
yeah, yeah,
So okay, so yeah,
yeah.
the one that you have for Windows is called what again? Type
Type
what's
VNC,
that's right.
TIGHT VNC.
Yeah, yeah. I see the question. Does Tight VNC work for Mac? I experimented a little bit, and the remote Ripple worked the best. So
Oh,
it's a free
okay.
one too. Remote
Yeah,
Ripple.
yeah.
I'll type it in.
All right. So I talked about the built-in Wi-Fi channel analysis. Here you can see like this is a look at 2.4 gigahertz band. You can see the different Wi-Fi channels and see what their signal levels are. So this is for troubleshooting Wi-Fi systems. The cable test, this is included with the frequency coordination license. Now, this will require some adapters that are not included with the RF Explorer Pro. Now, typically, we use BNC connectors on our coax cables in the wireless mic and in-ear monitor world. So what you'll need is SMA male to BNC female adapters. Excuse me. And you'll notice this protective ridge around the SMA connectors, and that's there to keep them from getting, damaged or something like that. Um, Now that makes the spacing a little bit tight. When I bought BNC to, SMA to BNC adapters, wasn't quite sure what would fit, so I bought a couple different types. These are pretty inexpensive. I buy them by the handful from like Amazon. You can get them in a lot of different places. Amazon, a lot of different, electronic supply places carry them. But I was pleased to find out that the the larger one here, which is a lot easier to thread onto the SMA connector, is will actually fit. I was afraid that it wasn't, but it threads on really easily. This one here works perfectly well, but it's just harder to get in there and thread this hex barrel onto the connector with. So that's just a little user tip. These are easier to thread onto the adapters than this type, though either type works perfectly well. Okay. So to do your cable test, you would use the RF generator output and the RF input. Okay. So that's where you would connect your cable across. Okay. Now the RF Explorer Pro is going to put an RF signal into the cable and measure what comes out of it. Okay. Now, when you set up the your cable test, you can assign a name to your cable, so that if you have multiple cables, you can give a name to each one in the right here, and then the next one you will have to put in the type of cable. There's a drop down menu where you select the type of cable that are of coax cable that you're using. Now, uh, that's important because the RF Explorer Pro has to know what type of cable to know what sort of characteristics that cable is going to have. So typically, what we use at RF Venue is RG8X, which is a pretty low loss cable at a pretty decent price. It was a good, you know, uh, good matching point of performance and price. RG58 is a common coax cable also, but it has higher loss. LMR 400 is really low loss, but much more expensive. It has about, I don't remember how many, but at least I think about 15 different types of cable in here to select from. Then you put in the length. Uh, the default is in feet. You can also use metric measurements just by going to config and telling you want to use meters or something instead of feet. Put in the length. Okay, so now the RF Explorer Pro knows what type of cable it is and how long. So it knows what should come out of that cable. When you run start, it does the test. And if it's a good cable, you'll get this tall green bar here. If you have a somewhat lossy cable, it'll be, um, you'll get this shorter yellow bar. Um, if the cable's really going bad, it'll be orange. And if it's just outright damaged, you'll get this red bar, and I'll tell you this cable is bad. Now, this is important to test cables because if you have, if you suspect that you have bad reception on one of your antennas, it's a good thing to test the cable before you go about replacing the antenna because cables get abused, they get damaged, stuff like that. It's a lot more likely that you're going to have damage in the cable than in the antenna. So, and it's a lot easier to replace a cable than to replace the antenna. So, check the cable first before you suspect the antenna, and then be, you know, you'll be good to go with troubleshooting your system.
Hey,
Now, being a
Bob,
ham, yeah,
I was going to say, do you want to segue into the antenna and filter testing? And I think we need to clarify when you're setting up your LAN for remote control of the device, how you're discovering the IP address. So when you feel the right time for that is. But do you want to segue into the other testing parts now, or wait?
we'll let's go through the cable test first. And being a ham radio operator, I've got a whole bunch of coax cables laying around, so I just ran tests on a bunch of them. And yeah, 1 foot RG58, 3 foot RG58, yeah, 6 feet of RG316U, which is like this little thin coax cable. They're all good. I didn't want to go damaging my cables to just to show what a damaged cable looks like. But it's really simple and easy to do this cable test. Okay.
The main thing is if you terminate your own cables and you
Oh yeah.
discover a short, you will not get performance if you have a shorted antenna cable. So
Yeah.
it's always a good idea, especially if you're renting cables for your gig and you want to just see what they're doing. Not many people test RF cables, honestly. So you got to do it yourself.
Yeah. Yeah. I know everybody kind of like views RF cables as like something that, okay, here's a cable, let's use it
Yeah.
without verifying it first. And yeah, so especially if you're doing like shows where it's not a permanent installation, you're bringing out cables, setting up your system for maybe a one-off show or whatever. It's a good thing to test your cables periodically, and especially before every show, just to make sure that they work
Well,
fine.
definitely the whole thing about the cable testing is just to sum this up is if you're on a gig and you're asked to do a rig for someone and you say how many cables you need, always ask for more. And as soon as you get the cables off the truck, you test them if you haven't been to their shop yet. So as a freelancer, you're designing things for people, but it may not be your own cables. You wouldn't really travel with cables most of the time. So as soon as you can get to test them, which means as soon as the truck unloads, you get right to it, and that's when you know where you're at. It's a nice tool for that.
Yeah.
I wanted to call out one question, guys, as it has to do with this that's live here. Do you have to calculate the extra loss for the adapters?
No, it's the as long as they're not like really bad quality adapters, but these really just go right on the connectors. There's hardly any insertion loss, and
It's usually less than one, right?
yeah, much less than 1 dB. So,
Cool. Thanks.
yeah. Okay, so included with the um, the cable test is, the frequency coordination function and cable test are both combined in the same license. Now, when you go into the frequency coordination mode, uh, this allows you to build a global inventory of all your devices. Now, one kind of misleading thing about this slide, it's something probably I should update it, is that you only have to put in each uh, device type that you're using, namely the brand, model, and the band. You only have to do that once, even if you have multiple ones of each, because the global inventory is just for knowing what items you have, not necessarily how much of each one, and it'll save that way. So actually, when you save the global inventory, it will just ignore the multiple, the repeated information. But the once you have the global inventory, you do a separate project inventory for each project. Now, the project inventory is where you will designate how many of each device you're using for that project. Okay, so the you can build as many project inventories as you need to, and the devices that you put into the project will be saved with that project inventory. You can assign names to the devices within the project inventory. So if you're using for particular vocals or particular characters in a play or musical or particular instruments or whatever like that, you can assign names to them. This is also usable for in-ear monitors as well. Okay. So when you set up your frequency coordination for a project, you can assign exclusion zones. Okay, and this is important because uh, you'll want to exclude TV stations, even though they'll show up in the spectrum analysis. It's good to know what TV stations there are, just so that if they're not particularly distinguishable in the spectrum analysis, you'll still want to exclude those zones. You can also exclude nearby wireless users. So if um, a theater a couple doors down or a church or something like that is using wireless mics and in-ears also, you can find out what frequencies they use and add those to your exclusion zone. So in the configuration for the project inventory, you can assign names to these exclusion zones. Okay, and they're saved with the project. So let's say you got a exclusion for a couple TV channels, maybe the Majestic Theater down the street, whatever. And you set your threshold above the spectrum, in the above the noise floor in the spectrum analysis, and then you press calculate, and it will give you a table of recommended uh, wireless mic and in-ear monitor frequencies. Now, the uh, it, the device will know what frequencies are available for each type of device because it's in its database. So that's one of the reasons for uh, inputting the brand and model and band of each device. Okay, so it will also produce a CSV file if you want, and you can double check it with against Wireless System Builder if you want, or any other frequency coordination software. And it will also um, give you a PDF report if you want to, keep a record of it. Okay.
Hey, Bob.
Yeah.
One question is there a CSV import for using frequency coordination? But I think most of the time you're going to use the live scan.
Yeah. You would use the live scan typically, because
So
That's
I think Adam was going to say something, but
Yeah, I think that question actually had to do with the inventory for your
oh, okay.
project. So I don't
Yeah,
believe there's an import for that, but there is a list of the major manufacturers. And as the device grows over time, more will be added. But you can also put in custom models. So if you don't see
yeah,
it in the inventory, you can just add, as long as you know the band and the step kilohertz, you'll be able to
yeah,
enter it in. I think it defaults to 25 step.
yeah,
So it's pretty straightforward.
yeah. And the importance of doing frequency coordination is so that you don't have frequency combinations that could cause intermodulation products that compete with other desired frequencies that you're trying to receive. Okay, because intermodulation, you get these sum and difference frequencies, and they tend to crowd the the very spectrum that we're trying to use for our wireless mics. Years ago, I wrote a program at Sennheiser that did this calculation. Now it's just simple arithmetic, addition and subtraction, but the number of possible combinations grows exponentially with the more channels that you do. So rather than adding and subtracting 40,000 times, let the device do all the number crunching for you. So the
Bob,
the
when I was going to
yeah,
mention, so yeah, finish your statement. I'll
yeah. So the frequencies that it comes up with will will be specifically calculated so that any intermodulation products won't compete with the frequencies that you're trying to do. You can also select um, fifth order intermodulation calculations, which are less common than third order, and if you go into config, but it's there for when you need it. What were you going to say, Richard?
Okay, so I'm just going to basically say the goals of what you're going to need to do when you're coordinating and setting things up. And I'll say it real quick here, but it's something that everyone should do consistently. And the first thing is you have to avoid TV. And in order to avoid TV, you have to have a spectrum analyzer to double check how
Yeah,
strong is coming in. You can use a database, but you really don't know until you fire up your spectrum analyzer, you put it in your room, and you know what's coming in. So as soon as you avoid TV, you figure out what's the best open channel, what has the best noise floor, which means the lowest. And then when you're coordinating, you're going, okay, I'm going to put these items in this channel, these mics in this channel, but ultimately your coordination has several levels, meaning you need to coordinate the items that are close together first in physical distance. So in
yeah,
your monitor, transmitters in a rack is what you concentrate on first, and you 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 use the robust settings, meaning you should check on 3 transmit testing because your transmitters are super close. What happens is when you get transmitters close together, they start to feedback. In the RF world, they feedback and cause this loop, which causes the harmonics, which is called the intermods. And once you start coordinating uh, ears first or the most offensive, let's say, transmitters with their placement, then you move on to the items that are not as close together. But without the spectrum analyzer, you can't really do a good coordination at all. You're guessing.
yeah, yeah. And with TV channels, uh, the digital TV stations get reallocated sometimes.
Yes.
Sometimes if you pick up your TV, if you do your broadcast TV watching over the air from an antenna, every once in a while, a TV station will say, on this particular date, you'll need to rescan your TV, and that's why modern TVs have this scan feature where it just runs through and looks for the available TV channels and then knows what's available and assigns them to the channel number. Now, the channel numbers on TV stations today are just virtual channel numbers. They don't necessarily correspond to the frequency, that slice of frequencies that they use. Unlike in the old analog TV days, where if channel 30 was on a certain slice of frequencies, channel 14, okay, that's 470 to 476 megahertz, and so on. They're all over the place now. Even channels with low, what used to be called VHF numbers, are now often up in the UHF spectrum, and they're all over the place. So you have to know actually what frequencies they're using. So the spectrum analysis is your first line of defense, and if you have a database, a current database of what TV channels are being used in your area, that's a backup.
Yeah.
Okay. The next function, tracking SNA, the scalar network analyzer. It's a scalar network analyzer is just a spectrum analyzer with a tracking RF generator. So this one uses both the RF input, where we typically put an antenna or something, and it uses the RF generator output, and that's what's going to generate the test signal. Now you can use it for testing any RF device that has an input and an output, like a bandpass filter, a distro. If you're troubleshooting something, you're not sure if a signal's getting through the antenna combiner or something like that, you can run the signal through, run it over a specific band of frequencies that you designate, and see, is that signal getting through? And if so, is it, are there losses at some point? Now, there are three modes of operation on the tracking SNA. There's insertion loss, which essentially is just the frequency response, okay? So here's an example of how I check the frequency response on one of our bandpass filters. Using the tracking SNA is a two-step process, because first you're going to need to normalize it, and that's seen in this first photo here. I just put a little BNC to BNC barrel connector in there and ran normalize. Okay, so that runs the signal over that frequency range and establishes the reference point for doing the analysis, okay? Then I insert the device and ran start, okay? So then it runs the signal through the frequency band and measures the actual frequency response of that device, okay? It will do multiple scans, like typically I think 5, and then give you the average, because you otherwise might get a little bit of a noisy signal. And this is the result that I get with this particular bandpass filter. So you can see it's a pretty good bandpass filter. Okay, and the two other modes of operation in tracking SNA are return loss, and return loss in expressed as VSWR. Now this is good for checking antennas. Now I used a mini circuits directional coupler. This is what you would need if you want to troubleshoot or check an antenna. And I didn't have a wireless mic antenna handy, so I have coax line running up to a 2-meter ham radio J-pole antenna in my attic. So I hooked up to that. And so I ran normalize first with the directional coupler attached this way. And then you turn it around and run the return loss by measuring the reflected RF energy that comes back from the antenna. So you see the normalize, you run it this way so that it can establish a baseline, a reference line with the signal going up to the antenna, and then run it again with looking at the signal that gets reflected back from the antenna. You want a minimal amount of reflection from the antenna. And this being a 2-meter ham radio antenna, I get a dip, the best return loss is in the mid 140 megahertz to 150 megahertz range. That's what you want with that antenna. And I selected uh, the return loss to be expressed as VSWR, and I'm down close to one, very close to one in that desired range too. So then I know that antenna works really well for that range of frequencies that I want. You can set this up for any other type of antenna that you want to use. In wireless mics, we're looking at 470 to 608 megahertz, so you can test over that range as well. Just set up your start and end frequencies or whatever. Richard, do you want to
Well, I
show
just
something?
I just want to say the whole goal of testing for return loss is, yes, you want to see what's reflected back from the antenna because you're sending signal out. If the antenna is tuned correctly, it'll go forward out the antenna rather than back to you. So if you want to understand this even more, you could run this test with no load on it and see everything come back, and then you do a test with the 50 ohm termination, and you see everything absorbed. Your antenna is a mixture of that, and where it's tuned to, the center frequency will hopefully be correct, and then you won't get that return information back. So whatever your antenna is ideally at its center frequency should be at the lowest point of the graph and below a 2 on the VISWAR, which is what you just show here. So that's perfect.
Yeah. And this is important for transmitting antennas, like your in-ear monitor antennas, but it will also tell you how well your receiving antennas are for the frequency range that you're using them in. So, VSWR is typically, associated with transmitting systems, but it'll also tell you are your receiving antennas working well?
Yeah, because all you're doing is to do the test, you're sending signal out of the antenna, yes, but your antenna is used for receive. You're just seeing what's coming back when you're sending signal out of the antenna.
Yeah. Because passive antennas have what's called reciprocity. How well they receive also, have the same characteristics the way it transmits.
Mhm.
Okay. So there we go. And so the zero span function, that's the last one that we're going to be looking at. And that's it's a weird name, but what it does is it's kind of like that channel power function that we looked at earlier. This narrows it down to a single signal. So you define the frequency and the bandwidth. So you can look at the carrier plus the sidebands of a particular signal. So if you want to know, if you want to look at how well a particular wireless transmitter from the stage is getting through the antenna system and the disc rows and all, and well, are you getting a good usable signal level from that? This is what you would use. This is a more advanced feature, so probably most users won't use it, at least at first, and maybe after they get more comfortable, with the unit, maybe go on. But this is there, and it's available for you to use. Like I said, this is a multi-tool, and back when I did wireless mics for Sennheiser in the late 80s, we had these big spectrum analyzers on the bench. It would have been impractical to me to drag that big thing out to a job site. But here we have all the spectrum analyzer and more functions all in a little portable device that weighs a little over a pound. It's really a different world now.
I would definitely support that and say, since this has come out, I've taken it out a few times, and the fact that it's so portable and it does what it does makes it a super powerful tool. I can travel with it way easier. I could do even more things than what my other spectrum analyzer can do. Um, and it's easy to like you can navigate really easy on it. It has things that I wish that I had too 20 years ago too. So
Mhm. Yeah, I want to show you what it looks like on the VNC viewer.
yeah.
Um, here we go. Okay, here's the. Can you see it? Can you see my VNC screen here? Okay. Now this is. I have the device on my bench right here, hooked into my network, and I can go into uh, say frequency, and let's say I want to change the frequency range. I can go to center and type in the put in the frequency range that I want to do. Let's say 550 megahertz, and maybe do it over 200 megahertz span, because that will include the RF spectrum that we want. Now, the the VNC viewer is really handy when you're doing frequency coordination, because if you're assigning names to things, you'll probably want to use like a computer keyboard rather than the touchscreen keyboard. Uh, there's nothing wrong with using the touchscreen keyboard, but it's more cumbersome than using a computer keyboard. It's that's just a user tip there. So here's what I've got now, and doing 450 to 650. Let's set the amplitude, set the top at let's do minus 20 dBm. And let's see the bottom at minus 120.
This whole setup process, you just want to give yourself enough headroom to see your reference signal coming in is
Yeah,
visible.
yeah. So this is here at my house in Chester, Connecticut, in the woods, in the hills, picking up very little. It's pretty quiet. I have like four computer screens, around me, so you get a little bit of noise down at the lower end. And looks like I've got a little bit of a TV channel coming through here, but hey, that's what I've got here. And like I said, I can use the screen instead of the touch screen, so um, you can go into power channel if I wanted to set up a frequency band on there. Um, oops. No, here. So,
Hey, Bob, real quick here.
yeah,
So I'm gonna. The question came in. Your noise floor looks high where you are. It does depend on your RBW setting. So
yeah,
I just want to show an example of my noise floor here in Phoenix. With what I'm
yeah.
doing. So that's TV coming in. So when you set up your SA, you have to realize on the RBW side, if you do automatic or you go into manual, you could fine tune what the resolution is and how
Okay,
the noise floor is.
yeah. You want to share your screen?
Oh, you can't. You can see the. Can you see my image of my RF Explorer
Yeah,
now? Yeah.
yeah.
So I'm switching to that as opposed to my camera. I'm not using my camera
Okay.
now. But I'm also using a VNC remote ripple to control it, and I'm using my mouse to go wherever I want to on it. So that's just an example of
Oh,
another noise floor.
yeah. Okay.
Hey guys, I got one question here. The noise floor is quite high. Are you using the local Omni antenna?
I'm using the local Omni antenna,
Yeah,
and it's
me
right
too.
next to my laptop. It's next to my computer monitors. I've got a desktop computer nearby, and I've got a bunch of other stuff. So yeah,
I'm using
it's
the Omni too on mine.
yeah. So typical, a typical noise floor in most, the average when you're, don't have like TV stations and other stuff nearby is usually going to be like around minus 85 dBm, give or take a little bit. But so I just happen to, you know, have a whole bunch of electronic stuff going on right next to my RF Explorer Pro.
Just a heads up too. I did a gig where the last 2 months ago where I was near. I'm not going to say the brand, but I was near intercoms uh, in Iraq, and it gives off sporadic RF that uh, if you're in the general zone of it, you would be going, "What is this?" So that's why in some cases we move the microphone antennas further away from that. So it came up as spikes, not like a bed of noise. It was like spikes that were as tall as the microphone carriers.
Yeah. Now, if you want to know about how you find the IP address of your RF Explorer Pro, like I said, you can use a discovery app, like I have Thing on my phone, which is helpful. You can also go into on the RF Explorer Pro, go into System, and then that brings out the Windows environment. It's a very reduced Windows environment. You don't have like Microsoft Word and other apps running on it, just the bare bones. But you go into Settings, and then go to Network and Internet. Go to Status, and then Properties, and then you can see the IP address right here. In my case, it's 192.168.68.123. So I just entered uh, that IP address when I start up VNC Viewer, and then it connects to the VNC server in the RF Explorer Pro. Okay, so
One thing to mention too, us as RF engineers, audio engineers, we need to have some sort of bed of IT knowledge, and to
yeah,
discover IP addresses on the LAN is like the most. You need to have that skill. Our systems are all controlled now with a network, and having the SA on the network like this is definitely super cool.
yeah. So that's our look at the RF Explorer Pro. This is like an introductory look. Um, we'll be developing more documentation materials online as we go along, as I develop them, and we'll have probably more, how-to videos in the near future. So I thank you all for joining us, and we'll entertain some more questions if we have time. Do we, Adam?
Yeah, we should. A couple more questions. We only picked out three because this has been
Yeah,
a really informative webinar with a lot of information. So I'm sure we'll, and of course, you can always email us. It's just Adam at rfnu.com, Richard at rfnu.com, and I believe Bob is Bob Lee at rfnu.com. Is that correct,
yeah,
Bob? I don't
yeah,
memorize your email address, but
yeah,
yeah, you can always email us. Oh, it's right in front of my face. I'm not looking.
yeah.
So email us with any questions, and we'll try to follow up with the questions that you did submit. But we're going to call out three questions for Bob to answer today. The first one is probably the most basic one. What are the key things to learn and practice in the beginning stage of RF management?
Yeah. Okay. That's a very multifaceted question. And the first thing you need to know is what uh, what RF spectrum, clean RF spectrum do you have available, and what frequencies are your devices capable of? Okay, and you want them all to be compatible. So you need an appropriate frequency coordination program to calculate the compatible frequencies. Now, I got a call about a year ago from a theater company not too far away. They were having problems with their wireless mic system, and so I went to visit what they had and see what they had, and they had um, a Shure system which should work fine, but they apparently had like their initial 8 channels installed by an integrator, and then they just decided, oh, we want more channels. They just willy nilly bought more Shure ULX transmitters and receivers, and just assumed that because they had different numbers on them, they were all going to work together. And turned out they had all different compatibility groups. They were using frequencies that are in use by local TV stations. It was a hot mess. And I had to tell them, like, you're going to have to like replace 7 of your 16 channels because they're just totally incompatible with the location that you're in. And I don't know how well they took that advice. I don't know if they followed through, but I told them this is what you have to do, and this is how you have to set up your your wireless channels. You know, so you you can't just make the assumption that using different frequencies, different numbers on the transmitter and receiver, that it's all going to work together. Okay, Richard, do you want to add anything?
Well, yeah, when we're talking about managing things up front, right? Is that basically what we're starting with?
I think so.
What do you?
Yeah,
So,
just kind of the basics of, getting into it. Where do you start? And,
yeah,
yeah.
when you approach a show or a gig or whatever you want to call it, you're there. They're relying on you to make it work. They don't know how. Most people don't know how it works, but we, as RF specialists, managers, whatever we want to say, we're there to work 100% for them, and we are constantly checking things and making sure when you hand the mic off, it's good to go. So yes, you have to know what TV you're avoiding. You have to know where your cleanest channels are. You start placing things in there, and then when you're coordinating, when you practice coordinating, you'll understand more that you start with certain things, and that's the transmitters that are close together. So the rack of in-ears is the first one. The microphones on stage that are within 2 feet of each other, like vocalist mics, when they all walk up together. But as you become more involved in the equipment that is more spread out, then you can let loose of your settings. Your spectrum, your coordination abilities, your frequency coordination abilities in our product and in other people's is the only way to truly accurately get to the best end goal. You can't guess this information. You can't just say, hey, I'm going to pick another number and it's going to work. Sometimes you have no choice and you run with it. But you have to understand your mics and in-ears are the most critical things that are coordinated more than definitely two-way radios aren't coordinated. They're just divided up within each other and they're spaced out because they're not all transmitting at the same time. So there's a lot of layers to this, but we focus on helping you with the ears and the mics, with our equipment to help clean up the antennas, with coordinating and using the spectrum analyzer. With all that in place, you're good to go. Your wireless mic can act just like a wired mic.
Awesome. And to the person that asked that question, I would definitely recommend our next webinar in April that Richard is going to be doing on RF coordination. So keep a lookout for that because I think it's going to be another continuation of this session that the guys have provided. So keep a lookout for that to learn about that. But we have time for 2 more questions, and I'm going to launch a poll because I want to see how many have attended our webinars before. So this is a good one. When is the best time to scan a venue for RF? An hour before? Right before?
You want to go first, Bob?
Sure. I would say as close to the event as possible, but allow yourself enough time to make any corrections that you might have to do. Well, first of all, you're going to have to do an initial scan to set up the frequencies that you're going to be using. The more channels you have, the more time you're going to have to allot to setting up those frequencies. And you have to be aware that if you do a scan later and you find something, you're going to have to react quickly to that problem. Now, the more accurate vision you have of the RF environment that you're working in, the better. So, what exists on a Wednesday afternoon might be very different from what exists on a Saturday evening. So, you have to understand what you're working with.